Hello guys and welcome to another video. Exponential equations are so interesting in the sense that with one question there are so many ways of tackling it. With this question right here, I'll be solving it in three different ways. So after watching, let me know which of the methods that you prefer. But before we begin, as you know the deal already, pause the video and give it a try first. And if you're done, let's get right into it. Like I said, I'll be solving this in three different ways. So this is going to be the first method. Cool. With the first method, we are going to make sure that the bases are the same so that we can equate their powers. And we are going to apply this rule in logarithm. We know that a to the power log base a of b, this is the same as b. This right here is b simply because it is the same as interchanging their positions, right? So it is the same as b to the power log base a of a. And clearly we know that this right here is giving us 1. So we will have b to the power 1, which is still b. And we are there. But before we proceed from here, I want to pass this information on. Those of you who like to know all the rules in logarithm, I'm going to do one-on-one classes online. If you're interested, I'm going to leave my Gmail in the description down below or my WhatsApp line. Contact me. We will talk about the pricing and the time that this will be carried out. Let's proceed right from here. So now that we know this, in fact, we can change this base right here to 5 with this idea. I'm going to write the 3 as 5, then to the power the same base, which is also 5, of this right here. That is 3 to the power 2 minus x. And still we have the right hand side to be 5 to the power x plus 4. That is pretty cool. Of course, let me put this in parentheses, and from one of the rules in logarithm, we can move the power to the front right here. So that, in fact, we are going to have 5 to the power 2 minus x times log base 5 of 3. And this is equal to 5 to the power x plus 4. Cool. Now we can see that the bases are the same, therefore we can equate their powers. So we are going to have 2 minus x times log base 5 of 3 is equal to x plus 4. Now check this out. We have x here, x in parentheses right here. Before we can get this x right here, we need to distribute this log right there. So basically, we are going to have to get rid of this quickly. We are actually going to have 2 times the whole of this, which will be 2 log base 5 of 3. Then minus x times this, that is also going to be minus x log base 5 of 3. And the right hand side, we still have x plus 4. Cool. And right from here, we can group like terms. Let's group those with x and those without x. I'll bring those without x on the left hand side. So we'll have 2 log base 5 of 3, then minus this 4 right here. And this is equal to, we already have x there. Then this is also containing x, which will be plus x log base 5 of 3. Now check this out. We have x here, x here. We can just factor that out. But before we do that, we have to keep the left-hand side, which is log base 5 of 3 minus 4. And this is equal to x out. Then the inside, we have 1 plus log base 5 of 3. Cool. We are after x, so what we will do is that we will divide each side of the equation by 1 plus log base 5 of 3. And we will do the exact same thing here. 1 plus log base 5 of 3. Clearly, we see that this and that will go, and we are left with x is equal to everything here. 2 log base 5 of 3 minus 4, all divided by 1 plus log base 5 of 3. And that is our answer. Of course, if you use a calculator for this, you are going to get x approximately equal to, of course, let me figure out what this will be on the calculator. Negative 1.56589. Is it 7? Yes, 7. If you use a calculator, approximately this is what you are going to have. Of course, this is the first method. This is how to go by it. Let's go to the second method. Okay, so with this second method, we are going to be applying some of the rules in indices. Let's start. On the left-hand side of the equation, we have 3 to the second power. Then the minus x right here means that this right here is divided by 3 to the power x. And the right hand side, we also have 5 to the power x. Then plus 4 means that this right here is multiplied by 5 to the fourth power. As simple as that. Now check this out. We want to group like terms in such a way that all the terms with power x will come to this side, then all the terms without power x will move to the left hand side. And we can do that by first multiplying this side by 3 to the power x and this side also by 3 to the power x. Then again, we can also divide each side by 5 to the power 4. Then dividing it will multiply this 5 to the power 4. As simple as that. Now check this. This right here will cancel out that. Then we'll be left with 3 to the second power divided by 5 to the fourth power. Then this right here will also cancel out that. And we will also have 5 to the power x times 3 to the power x. That is pretty cool. 3 to the second power is nothing but 9. Then divided by, what is 5 to the fourth power? Cool. Let's do it this way. This will be 5 to the second power or to the power 2 so that we can easily manipulate that. Now this right here could also be written as 5 times 3 or to the power x. Cool. So in fact, we are going to have 9 divided by 5 squared is 25. 25 squared, that is going to be 6 to 5. Is that it? Yeah, cool. That is that. Then the right hand side, we are going to have 3 times 5, which is 15, then to the power x. Pretty nice. Now, what else can we do? Of course, we have 15 to the power x right here. We can just take log on each side of the equation. Log 9 divided by 6 to 5, and this is equal to log 15 to the power x. And clearly, we can move this to the front so that we are going to have this right here is also the same as log 9 minus log 6 to 5, and this is equal to x log 15. Pretty interesting. We are looking for x, so we can divide this side by log 15. As simple as that. Log 15 so that this and that will go, and finally we are going to have x is equal to, those of you who like to play around with this one, this is the same as 3 squared where the 2 will come front and we will have log 3, then minus this is also 25 squared, so the 2 also come front and we are going to have log 25, then all divided by log 15, and that is going to be the value of x. Pretty much, if you use a calculator for this, you'll be getting what we had previously, so you can verify that. With the third method, I'm pretty sure that is what everybody likes. Let's go ahead and then take log on each side of the equation straight away, so that we also have log base 10 of 5 to the power x plus 4. And as always, let me put this in parentheses. We can move this right here to the front so that we are going to have 2 minus x times log 3. And this is equal to, we can also move this to the front right here so that we are going to have x plus 4 times log base 5. Now let's go ahead and then distribute this log 3 so that we are going to have 2 log 3, then minus x log 3. And this is equal to, we have to also distribute this log 5. So that the first term is going to be x log base 10 of 5, then plus 4 log 5. Pretty cool. We have minus x log 3. Let's transpose it so that it will be positive. And if you do that, I'll keep this 2 log 3, then minus this right here. So we're going to have minus 4 log 5, and this is equal to x log 5, then plus x log 3. Cool. Now, x is common, so we have to maintain this. 2 log 3 minus 4 log 5 is equal to, we factor out x, then the inside we have log 5 plus log 3. Pretty cool, huh? So, in fact, we are going to have something scary a little bit. We will have 2 log 3 minus 4 log 5, and this is equal to our x divided by, that is, if we divide this side of this, it can occupy here, but we can divide straight away, which will be log 5 plus log 3. So, ladies and gentlemen, that is our value for x, which is, like I said, you can also play around with this one, but I would like to keep it this way. 2 log 3 minus 4 log 5 divided by log 5 plus log 3. Actually, you can multiply this by that so that you still be getting log 15 as a denominator. So guys, that is pretty much it. Like I said, if you're interested in any of the rules in logarithm, I will leave my email in the comment section down below and contact me one-on-one. We're going to learn all the rules, how to apply them in solving problems, and that is pretty much it. See you again on the next video. Have a nice day. Take good care of yourself, and bye-bye.